So we have the BoeBot in a slightly different configuration this time. It'll look a little crab-eyed. Essentially what we have here is we have two LEDs, and they're mounted in these little plastic holders, and I don't know if you can see it, but they're actually clear and they're lighting up constantly, but you can't see them because they're in the near IR. And these black things here, let's back away, let's see if I can keep the focus. These, put it down for a second. These, point at it with something other than my finger. These black things here, silver with black, they're IR detectors. So right now the LED is lighting up because it can detect the camera, but if I put my finger in front of the detector, I can dance around here and the LED won't light up till I move my finger. So essentially what it's doing is the CPU there, it's constantly sending signals that are lighting up these LEDs. They're sending out infrared, and if it bounces back, like if I put my hand here, it hits the detector, and then that registers in the CPU, and the CPU then lights up these LEDs, and it also does something else. The basic program that it's running is it's always moving the wheels forward until it detects something ahead of it. If it detects it to the essentially it always moves away from anything it detects. So if it detects something to the right, it moves left, and vice versa. And if it detects something straight on in front of it, it backs up. Very simple algorithm, which leads to some interesting problems. The other thing that you can see is you can just do some simple tests. I don't know if you can see yeah, you can't see my hand. So I've got my hand out here and I'm moving it in until the LEDs light. You can kind of see I'm on the threshold here where they can just barely detect it sometimes. And if I go in a little bit further, they turn on constantly. If this turns out to be color dependent, so if you take it and you watch how close you can get to something that's white, you can get relatively close, maybe about it's a little bit less than a foot. But if you have something that's black, like this thing with art to store tools in, you can get pretty close, and it's still, in fact right now it's right on top of it and it's just barely sensing it a little bit. So it's very color dependent. Things that are black don't get detected well. So the other thing is, with only two sensors, there are some blind spots potentially. You can move it in certain ways that you hit the wheel, and sometimes it'll detect you, sometimes it won't. And potentially, if you had something that was very thin, you could have it come right down the middle and hit it, or come off to the side and clip it, depending on how it was moving. So it would be better to use it in conjunction with another sensor, like maybe a third sensor here that goes out straight ahead, or you could have tactile sensors either on the periphery or something that came out. They give you whiskers to use to detect an actual collision. The other thing is, if something comes in, if it's really low to the floor, it may not detect it, and it may bump into there. So the next thing to do is take advantage of my cluttery apartment and see how well it avoids things with this simple algorithm. And we'll find out that now I'm going to engage the motors so you can see the basic programming. So now it's heading off into the corner. can see it detected my shoe there. Now it's detecting that. The fact that it always just straight backs away from things that it's about to collide head-on with causes some problems. It can get stuck in a loop like it's getting stuck right now. Sometimes the randomness of timing will shift it eventually over a few minutes so that it'll back away. Sometimes it can sit like 10 minutes doing this over and over again. And I think this really tends to drain the batteries because it's constantly firing the servos back and forth, so it's kind of fighting itself. It's also constantly lighting up the LEDs and such. There is an easy way to correct it, though. You can just put your hand out to the side and tell it, no, don't go that way. So you can actually make it go around in a circle by constantly hitting its on the periphery there. Now it's kind of getting into another feedback loop where it's just hit the right angle, where it's sensing my curtains in the bleach bottle just at the right time. So I think I'm going to help it get out of this corner. And there you see it's actually, it didn't detect the black of the shoes until too late, but it's going to power through. But it'll probably clip the box there a little bit. Can't quite power its way out. So now it's heading off across the carpet. We'll have to see. It will probably turn into the fireplace. That's so interesting. So I'm going to shoo it if I can. See that it'll, no, it didn't quite detect the box. It wasn't quite on a collision course. So you can actually just let it sit and roam around for quite a while. Except for getting into little areas where, in fact, it might get itself locked here. So since we've already seen that behavior, I'm going to correct it again. There. It hit a blind spot. So you would have to spend some time aligning this a little bit better. And it may do a flip for us. No, it's not going to quite. I was kind of curious to see how it dealt with these plastic containers, to see whether it would be able to detect it or not. Let's see. Yeah, actually, well, sort of. It's kind of at a bad height for it, too. So, see if it'll back away from my foot. So it would help to mount these sensors a little bit lower. But you get the basic idea. So I'm going to show you a slightly improved algorithm where it doesn't get stuck in corners